So parallel and perpendicular lines are a pretty neat application for the point slope formula. And we need to talk about what it means to be parallel. Well, if I have two lines that are going in the same direction and never meet, those are parallel lines. That's how we define them in geometry class. But with algebra, when we talk about slope, we can say that these have same slope, but they have different points. So, which means they have different y-intercepts, which is going to be useful. Perpendicular, on the other hand, perpendicular means they form 90-degree angles. And if you notice, I just drew my XY axis or axes, and we talked about that, and those form a 90-degree angle. So those are perpendicular. If I have a line with some slope, a perpendicular line would look like that. And so when we draw it, we know that we can eyeball it and figure out what 90 degrees looks like, but we can actually come up with the slopes mathematically. And the way we do that is we have to talk about reciprocals. Okay, so my slope would be m in the first case with parallel, and so this would be m1 and that would be m2. They would be the same m. But with these, they're not going to be the same. They're going to be the opposite. And so what we're going to do to find a perpendicular slope, we have to talk about a reciprocal, and we have to change the sign. So let's write this down formally. So with parallel lines, I like to use this symbol. So if I'm given y is mx plus b as my original line, the line that's parallel to it will have the same slope. And in geometry class, we use it looks like an 11, but if you type it, it's the vertical bar on the keyboard, and it's two of them. That's the symbol for parallel. And whatever slope that I had in the original line is going to be the slope for the new line, the parallel line. With perpendicular, my perpendicular slope, and if you remember perpendicular in geometry class, it might have been a while, but we use an upside down capital T, kind of loosely speaking. That's my perpendicular slope. So again, if I'm given y equals mx plus b as the starting line, I want to find the perpendicular slope to it. I'm going to take the reciprocal and change the sign. So let's look at a couple examples. So find, it's not a line, it's d line. Let's do parallel to y equals 2x minus 5 and passing through let's do 1, 3. Okay, so I'm using my little parallel symbol here. You can write parallel if you want. So let's write down the information we have. So I want a parallel slope, and it's going to be the same as whatever I started with. So parallel to 2 would be 2, and passing through 1, 3. So I have a slope and I have a point, which means y minus y1 is m times x minus x1 is going to be our friend. And if we plug things in accordingly, I get y minus 3 is 2 times x minus 1. And I get y minus 3 is 2x minus 2. If I add 3 to both sides, y equals 2x plus 1. And if you were to graph these, and I recommend, so you try it. you should graph the lines and on your own paper and verify that they are indeed parallel, and they will be. You can also use Desmos or a graphing calculator. So if you don't have a graphing calculator on hand and you want to get quick pictures of what things look like, you can go to your browser or download the app on your phone. And desmos.com/calculator is wonderful. It's a really nice tool. Let's check out a perpendicular line. So is that what was it 1, 3 or 3, 1? We're going to do the same point and the same equation. So going through y, we're looking perpendicular, y equals 2x minus 5, and passing through 1, 3. So how do we do this? Well, my perpendicular slope, if m is 2, my perpendicular slope is going to be -1/2. And this is the one that we're going to use. Okay. And we're going through 1, 3 again. And again, y minus y1 is m times x minus x1. And this one's going to be a little bit more annoying because we have this fraction, but we're going to power through. So y minus 3 is -1/2 x minus 1. And we're going to go through, and I'm just going to be quiet and write. Mind your sign there. Oops. That's going to be y is equal because we need to add 3 to both sides. After finding a common denominator for my b value, the y-intercept coordinate is going to be y is -1/2 x plus 7/2. So I want to let you know that if there's 2 special cases again. If I have a 0 slope, then a parallel slope is going to be 0 as well. My perpendicular slope will be undefined. And if you want to think about that, horizontal line, horizontal and vertical are perpendicular to one another. So if you're given horizontal lines, you're just going to look at your y value to get the graph, and it's best to do these with graphing. And let's see if and if I'm starting with an undefined slope, so a vertical line, then parallel lines are also going to be vertical. But then my perpendicular lines are going to be horizontal. Let's do one example. So if I'm looking at y is 5, and I want perpendicular line going through 2, -1. Okay. So what we're going to do is let's sketch a graph real quick. And I'm just going to kind of estimate where everything is without the tick marks. So there's my line, y equals 5, that's above the x-axis, that's parallel to it. And I want to go through 2, -1. So let's plot that in red. So 2, -1, let's say, is there. And I want to know what the equation of the line that's perpendicular to y equals 5 that passes through that point. And what I can do is, I know it's going to be a vertical line. I can just drop a vertical line that passes through 2, -1. And it turns out that that's going to be 2, 5 right there. If this is 2, -1, hey, wait a minute, x is 2 is going to be my line that I'm interested in. And that's how I would handle that.